I like to summarize my mission statement for the Data Science Institute at Columbia with this 3-word tagline, data for good. Data for good, of course, means using data to benefit society, for the good of society, but it also means using data in a good manner, and that's the responsible use part. So I'm only going to focus on the responsible use because I think that's of such a timely topic, and of course, it's something that I really want to emphasize to the entrepreneurs in the audience, that you need to be paying attention to this now when you start your company, and the designers and the engineers should be paying to these issues now, not after the fact. To be honest, you do not want to be in the hot seat that Mark Zuckerberg is going to find himself in on April 11th in front of Congress. So that, you get it? All right. So what do I mean by responsible use? I use this 5-letter acronym, FATES, Fairness, Accountability, Transparency, Ethics, Safety, and Security, to summarize, just as a checklist reminder of the kinds of properties that we would want of the systems that we build and design to have. To you and me, some of these properties look a little squishy, and that's the nature of the beast, but it also is a challenge to the technical community, and by that I mean the scientists, engineers, mathematicians, and so on, to formalize some of these definitions, to build tools, automated tools that can help check our models, our algorithms, our data sets against some of these properties. What I want to do in my time with you is just to run through very, very quickly what I mean by some of these properties through examples, what progress has been made in terms of the technology for checking some of these properties. And believe me, this is all very new. It's not like there's a book written on any of this. And some of the articles that I cite are 2017 publications. This is all really, really new. We're still trying to figure this out. But as you can tell from the headlines, it's an important topic for us to figure out. So let me start with fairness. And before I can tell you some stories that can motivate why understanding and checking for fairness is so important, let me start with a little primer on setting the context in terms of machine learning, AI, and so on. So first of all, we start with an algorithm. So this is a bread and butter artifact that we invent. In computer science, we invent algorithms all the time. Algorithms are used everywhere. They basically take a set of inputs and produce an output. In this particular case, think of the inputs as being data. It could be big data. It usually is big data these days. And I'm not distinguishing between training sets and test sets, just data, lots of data. We start with the data, we feed it into the algorithm, and what's the output? A model. And this is what I mean by a machine learned model, because the algorithms I'm thinking about are machine learning algorithms. With this model, this is what people are really interested in producing with these algorithms. When I give you new data, brand new data you've never seen before, the model is able to do a classification or do a prediction. In the context of this talk, I'm just going to simplify matters. So a classification output might be, if I give you an image, you say there's a cat in the image. It's as simple as that. So it's a cat classifier for images. You know, I might have a different classifier that says there's a dog there, or there's a person there. I'll say, so the model is going to produce a classification. It's a cat, the image is an image of a cat, or it's not. Binary. Or the model might predict something. So it might predict where you're going to click next. It might predict how long you're going to spend looking at this item on Amazon. It might predict what movie you're going to watch on Netflix next. Everything we do on a daily basis with the web, with the digital world, there's some prediction going on based on all of our behavior in the past, and I don't even have to spell this out for you because you're reading the news as I am. So in any case, what can go wrong? What can go wrong? Well, there might be, what people have been criticizing that algorithms might be biased. I'd rather turn your attention to something more fundamental that might be biased. And that is the data you feed into the algorithm might be biased. In fact, the data that you feed into the algorithm very likely will be biased because all that data is reflecting real-world data, and real-world data likely inherently is biased. So you start with biased input, and you basically taint the entire pipeline, potentially. Than anything, the model might be biased, and the classification might be biased, the prediction might be biased. You're kind of hosed from the beginning. So that's the situation we're in. And now let me explain some examples of where this bias has shown up, which is alarming to us as citizens in society. So the first example is this very well-known example that came out of an article by ProPublica. How many just have heard about this story? Okay, so that's not enough of you. This ProPublica article raised the awareness of the public to the potential that there's bias in data and thus bias in the model. What this article said is that there are these proprietary algorithms that are used by judges in the United States to determine whether the risk of reoffense, recidivism, they use this black box to give a risk score to a defendant. And the ProPublica article said that this risk score, this black box, was almost twice as likely to mistakenly flag black defendants than white defendants. So this clearly doesn't seem fair, especially in the laws of the United States, and there was an uproar. You should realize that this risk score can go wrong in both directions, if you will. It can give a low risk score to someone who will reoffend, and it could give a high risk score to someone who will not reoffend. So it can go wrong in both ways, and sure enough, this ProPublica analysis showed that this black box algorithm went wrong in both directions. And that caused a lot of excitement and brouhaha, and lots of people then subsequently looked at the data that ProPublica was able to get from this company, and there were white papers done by various communities, but it all settled down eventually with some technical people, some colleagues of mine in computer science that basically said, you know what? It's actually impossible to satisfy two different reasonable notions of fairness at the same time. What the black box was doing was trying to satisfy one particular notion of fairness, and what ProPublica was arguing for was a different notion of fairness, and these two notions of fairness are incompatible. And there's basically a paper that spells this out mathematically, and on the one hand, this kind of settled the argument, settled the debate in the community, but the most important thing from my point of view is it raised the awareness that there's not necessarily one notion of fairness that makes sense for all cases, all contexts, all situations.